what I was getting pretty universally, so that means that you got half of yesterday's lesson for sure, is 12. That's our first term. And then after that, we're just subtracting 7. So we're doing 5, then we're doing -2, and we're doing -9. That's it. That's all that you needed for your sequence. Now let's go the other way. So the rest of the lesson was doing it the other way. Given a sequence, I want you to given a sequence, I want you to write the rule. So we're going the other way now. So let's take a look at what our sequence is here. Sequence is going to be. So now I want you to write the rule. Take a second and go and write that rule. Mm-hmm.
For like the second time when we're supposed to do multiplication or division, I found that most of the problems were still addition or subtraction.
Oh, really?
Like even in the answer key when I checked my answers.
For the geometric one?
Yeah.
Weird, because actually, I didn't make those answer keys, but I went through and did it. And I didn't remember that. But if you want to, Ben, after class, you can just show that.
Okay.
And maybe we just need to change that for next year. But yeah, most of those, they were supposed to be the geometric type.
Okay.
So. Yeah. So, moving forward with this sequence, and we're going to write the rule. Our first one, actually before we move forward, can I have everybody turn theirs towards me so I can make sure that we're on the same page here? Can you zoom in just a little bit? Awesome, awesome, awesome. Great, great, great. That looks great. Somebody else want me to check theirs? Awesome. So yeah, so based off what we just saw there, our rule, u of 1 is equal to 4. It's pretty easy, it's given. Second piece, u sub n is equal to u sub n minus 1. And then we're just finding out the common ratio to multiply this by. So we can just take 16 divided by 4, or we can just see it and know that it's 4. Then our last piece, n is greater than or equal to 2. We know that it's 2, so we're just going 1 up from our first given term there. All right, seems like everybody's got that down pretty well. So let's move on here. So, going from here, what we're going to be doing today is we're going to be basically making this piece of the equation more complicated. We're going to be focusing on geometric, so we're going to be making this a little bit more complicated and kind of defining that, giving that a term or a name, a definition is the better example. And then we're also going to be plugging it into our calculator so that we can do these things fast, so that when asked us for the 11th term, we're not sitting there and having to do all that. So that's good. So, with that being said, why don't you try this? I'm actually going to show you one here to show you where we're going to go to. So, u sub 1 is equal to 10,000. These are the type of numbers that you'll see because they're generally talking about like a population or something like that. Then u sub n is equal to u sub n minus 1. Multiply that by 1 plus 0.25. So this is where we're going to be going. And I know that it's simple to say, well, isn't 1 plus 0.25? Isn't that the same thing as saying 1.25? Couldn't we just multiply that by 1.25? It is, and you can say that. The reason why we're going this route is because yesterday when I was showing examples, we had some really complicated ones. And this will just help you to see that and differentiate, because we're going to be differentiating between the common ratio and then what's our growth rate or our decay rate. So with this one here, this plus, what do you think? So that plus is making this grow. Because if you multiply something to get the next term and it's always being multiplied by 125, you see how that is going to grow? That's going to continue to get bigger and bigger and bigger. The opposite is true when you get a minus in there. That's going to decay. It's going to slowly get smaller and smaller. So with those two pieces there, the reason why we like to do this is because this number here is called your growth rate, or your decay rate. It's just this piece here, it'd be 0.25. It's also referred to as, in your homework it is referred to as this, percent change. So you could also convert that to a percentage and say it's 25%. It's growing by 25%. So with that, the big thing that we want to separate before we get into our calculator is we want to be able to separate what is our percent change, same thing as saying growth or decay rate, and what is our common ratio. So the common ratio is always going to refer to this whole thing, because in our last example, we were saying that this multiplied by 4, that's our common ratio. That's going to be different than this here. The percent change or the growth rate, that's going to be just that piece of the equation there. So we want to be able to differentiate that because we need that type of stuff to plug it into our calculator accurately. So let me do this. Let's get another example here. And I'm going to have you answer a few questions for me with this one here. So let's do u sub 1 is equal to 1,000. And we'll do u sub n is equal to u sub n minus 1 multiplied by 1 plus 0.45. N is greater than or equal to 2. And what I want you to find is I want you to be able to find is what is the common ratio, and then also what is the, I'll call it percent change because that's what it does on the worksheet, percent change, also called the growth or decay rate. So why don't you do that? Why don't you do that right now? Pause the video. So coming back in, the common ratio. What do we get for our common ratio? Who can help me out with the common ratio? Or let's right back there. Yes. 1.45. That is correct. Because our common ratio is always going to be different than our percent change. And the common ratio is always this whole piece there. So 1.45. Then moving down, can I get some help with the percent change? Right down front here. 45% growth. And it is a growth. Perfect. Pretty simple, pretty easy to see. Like I said, there's nothing wrong with putting this together. It's just about where you're going. By the end of the week, you're going to want that separate out because it'll be easier for you to see what that change is when you're getting when you're putting stuff into your calculator. So let's take a look here. Let's maybe jump all the way into our calculator problems here. So why doesn't everybody pull out their calculator? And we're going to get started on some of that stuff. So we're going to do a little bit of showing how to put these equations into our calculator. So our first step is we want to get everybody back to ground zero. So we're just going to clear our data. If you have any programs or anything that are saved in there, you might not want to do this, but most people it's going to be totally fine. So, and you would know if you were programming something into your calculator. So we're going to start by pressing second, and then we're going to go to the plus sign here, and then we're going to go to 7, which is reset, go to 1, which is all RAM, reset RAM, go to 2. And then you should see something like this. Once you check with your neighbor, make sure that they have the same screen that you have. So I'll just get the keystrokes back up here. So second plus, you do 7, then you'll be clearing all RAM, and 2, and your keystroke will be right up here too. All right, does everybody's calculator say RAM cleared or some variation on that? Awesome, that sounds good. So moving forward here, the second piece we have to do is we have to change our mode. So we've got all these different modes. We've primarily been operating in function mode, but all we want to be in is sequence mode. And don't go down too far. If you go down too far and you see something else that's not letting you hit sequence, it says like sequential, I think, go all the way up to the top of your modes until you see this function, parametric, polar, and then get it over to sequence. Somebody need any help with that? It should be under mode, and then just about the 4th option, 5th option down there. You'll just slide that over to sequence. Why doesn't everybody check with their neighbor? Compare screens. Make sure that yours both say sequence. Sequential, yep. Yep. So this is that one that I was talking about that's too far down. So if you go over here to where it says function, and then you slide over to sequence there. That is correct. Yep, that is correct. All right. This is. That is correct. Yep. Yep. All right. Everybody's calculator says sequence. This is the part that you'll figure out if it does or doesn't. If you press the Y equals, the screen looks a little bit different than what you're used to. You should push, yes, you need to push enter to let it know that you've selected that. Yep. So, and don't get freaked out by this screen. This screen actually looks similar to what our function screen does. I'm just jumping back to function, where we have all these different functions we can input. It's the same idea in sequence mode. In sequence mode, it's just giving us multiple options for sequences that we can figure out. So all that we really care about are these top 3 lines. So here's the big takeaway from this. The big takeaway is that we've been writing our sequences as like U sub 1. This subscript here, the calculator doesn't do a subscript. So how it says subscript is it does it in parentheses, just like that. So every time that you're trying to do some sort of a subscript, you need that in parentheses to let it know, hey, this is the subscript. So our first step here with this is we are going to give the n minimum. So this is saying what's our starting U? So like we've been talking about how this U sub 1, that this could be like U sub 2009, this could be U sub 0. In our case, with this problem that we're doing, which is going to be right down here, our U is U sub 1. So this is just saying, what's the minimum term? This is helping it figure out what the domain is for that. So n minimum is 1. The second piece here, so we've got U, and then in parentheses, n. So that is saying U sub n, because it can't do the subscripts, is equal to, kind of looks like a lot like our starting terms that we're getting over here. U sub n is equal to, so now we just need to put in this U sub, UN minus 1. U sub n minus 1. There we go, third time. So, jumping into here, we want to tell it U sub n. So the U is where your 7 key is, but 7, second, 7 will get you your U. And then since we're doing subscripts, we need parentheses. So we're going to do a parenthesis. And then we're going to say n, which n is the same key as your x key. So it's what you use a lot with your functions. Minus 1. And be sure that you push the minus key. Don't push the negative key. The calculator won't like that. And then we're just going to close that. And now so far, we've got our u of n is equal to u of n minus 1. That's what we've got so far in this line here. So to finish that out, we just need to finish this out here. I'm going to break this up and say 1 plus 0.05, just to keep our form consistent there. But now we're just going to put that in. Like I said, you don't have to put it in this type of form. I just think it's helpful for going down the road. So multiplied by, and I'm going to do 1 plus 0.05, close that parenthesis, and we've got our equation. Now we're missing one last piece to this. The calculator doesn't need the domain because that's it's one of the things that it's smart with. So if it doesn't need a domain, what's the one thing that we haven't told it yet? We did tell it the minimum. Oh, what that value is? Exactly. We haven't told it what that starting value is. So guess what? That's what our last line is here. So then we just plug in 6 for our starting value. And so, as you can see, so n minimum, this is saying n minimum is equal to 1. So that's effectively saying u sub 1 is equal to 6. That's how that works. Then we've got u sub n is equal to u sub n minus 1 times by 1 plus 0.05. So what you can do here is if you want to see them in the list of a table, you just go second graph or table, and then you'll see them in that table. And you'll notice that the calculator is smart enough to know, hey, I can't find 0 because you told me my starting term was 1. So it errors out. So if I go up here, all these are going to be errors because it knows that I can't find that because it's not defined. So now we've got our table of values here that we can find and quickly see, and you can always scroll over onto the number and it'll give you the complete decimal instead of just chopping it off there. But this question here is asking for what is the 100th term in this recursive function? It's going to take me a little bit to scroll down to that. Nah, I don't really want to do that. So if I go second quit, I can just tell it to calculate one specific term in the function. And I can do that by saying second u. So I'm saying find me u sub 100 because the parentheses are that sub. Enter. That's that. That's what my 100th term is. Why doesn't everybody compare with the person next to them? See if they understood. See what you get. Ask any questions. This part here. So you didn't get that. You didn't get that number. You didn't get that value. Plus 0.05, 6, sub n equals 1. So, right, you might want to... Did you get that same value as me? Everything on my end looks right. It might mean that you maybe punched in the formula wrong. It looks right to me when I'm looking at it. So I'm looking at it. So you're doing plus 50 instead of 0.05. Yep. Yep. All right. Did everybody else get that, or did they figure out? Did they figure out what they're doing wrong? If you ever get errors, if you ever get something weird, it's always because you plugged it into your y equals screen incorrectly. That's the only thing that can possibly go wrong. All right. So let's do this. Let's do one of these here. We're going to move ahead and do an example, and we're going to use our calculator to do it. So why don't you do this example here, where you're given this sequence, and I want you to answer all these questions here and go from there. Going to pause the video. So looking to see what people got here. What do we find out is our common ratio? What do we find out is a common ratio? Let's go right down front here. 1.2. And how'd you get that?
I did 24 divided by
24 divided by 20, because that's creating our ratio. that is equal to 1.2. If you don't think that's right, try doing this one. 28.8 over 24. That's also going to equal 1.2. That's that common ratio that each number is being multiplied by to go. So, and I don't love this being on the same line here. It's just asking generically for what is the growth or decay. It's not actually asking you for the percent change. But is this growth or is this decay? It's growth. Awesome. So we've got our common ratio, 1.20. It's growth. Let's use the dice of chance if I can find them around here. Of course I can. Let's go row 3, person 4. 1, 2, 3, 4. What'd you get for your percent change? 20%. That is correct. And remember, our common ratio is always going to be different from the percent change or growth or decay rate. 20% is always, this is always different from that. That's the key piece to pull out of that. Next one, let's go recursive form. Let's go row 1, person 3. Then minus 1 times by what? 1 plus 0.2. Perfect. And then, of course, in theory, you'd be writing your starting terms too. So what's the rest of the formula there? E of 1 is equal to 20. Yep. Perfect. That's what we're looking for. Last piece, 23rd term. Let's go row 6, person 1.
So yeah, the 23rd term,
1,104. Point. Can you give me those decimals again? 122.878. Is that what everybody else got? If you look at this in the table, I believe the table chops it off right there. That is a little bit too close to round 2. You might get that wrong on a test. It's usually safest to actually plug that into your calculator and figure out what the actual 23rd term is. That's where we're doing it in this screen here. We're saying U of 23 is equal to that number. So nice job there. That's most of it. The last little piece here that's pretty easy is just graphing these pieces. So we're going to jump down to one of our graphing ones. So we're going to do the same process here. Let's go and let's find the common ratio, whether it's growth or decay, what the percent change is, and then I'll show you how to graph this sequence right here. So here's your sequence right up here, answering these questions, and of course writing the formula. Let's go back around. With the sequence, what is the common ratio? Let's go row 2, person 5. Hopefully that row has 5. Yes, 5. Awesome. What'd you get for your common ratio?
Common ratio. That would be
3. Did everybody else get 3 for the common ratio? Who agrees? Raise your hand. Awesome. Everybody agrees. Great. Okay, let's go row 4, person 4. 1, 2, 3, 4. Person 4. What'd you get for this one? Is it growth or is it decay? 1, 2, 3. Yes, Miss B in the back. So why don't you do this guy here? Is it growth or is it decay? It's growth. Perfect. Nice job. All right, let's keep moving down here. So percent change. Who can give me percent change? This time I'll go with hands. Yes. 200%. Who agrees that it's 200%?
We show how we got that.
Ah, we have some dissension. Is there another answer that we think that it might be?
300%?
Do we think it could be 300%?
No, increasing by the number. It increased by 14.6.
Okay, silly.
Okay. So let's get this straightened out here. So we got 21.9 divided by 7.3. Let's plug that into our calculator. Yep, it's 3. That's what we did. Thank you. So then So then this is a weird one. So technically, what the percent change would be, it would be 300, and I know that breaks form. That's a little bit weird. So not necessarily right, or excuse me, not necessarily wrong. This is a weird example. Most of the time, when you're doing this 1 plus, and then in this case, we're saying that it's going up by 3. This is an odd case. Most of the time when you're doing this, and this is specifically why we're doing this example, is because most of the time when you're doing something like that, this number here, it's going to be like a population, or it's going to be an interest, it's going to be a mortgage. That type of stuff doesn't increase by hundreds of percents. So technically, your technical percent change would be 300%, but I just want to be sure and point that out that, that once it gets over 1, it kind of breaks form. It kind of breaks that rule. Most of what we're going to be dealing with is going to be between 1 and -1. I'm blanking what the variable would be here. So this is the percent change. Most of our percent changes are going to be between 1 and -1. So this is a weird one, and that's part of the reason why I decided to do this one. So don't necessarily love the problem, but it does kind of bring that question out. So yes, so technically it's 300. 200 is certainly what could have very easily been written. So so our last piece here is just write the recursive formula. Let's go here. Let's go right down front. Yeah. Times by 3. Sounds good. We can also write in that weird form in this example. I don't necessarily love that form, so times 3 is perfectly fine with me there. And then what's for the rest of the so what else needs to go in this function? 7.3 or 2. Yep, exactly. Because it is off of 1, or technically you could have put whatever. No, yes, because you did 1 there, you needed 2 there. All right. So graphing. This is our last piece to this lesson. And then we're going to get some time to work on our homework. So with graphing, this is nice because they gave us the first couple of numbers. So this is our first term. This is our second term, third term, fourth term. So this part right here, this is referring to your x-axis. All these numbers here, this is referring to your y-axis. So all you're doing is you're just graphing it like that. So we've got 7.3. So we've got 1. So our points, let me just write this a little bit better over here. So our first point would be 1, 7.3. What would our second point be, row 2, person 2? Right down here. Correct, 221.9. So it's a pretty simple concept. You can see it down there. We do have a graph down here we can put on. It doesn't have a lot of great tick marks, so say this is by 10. So 1 roughly there, and we're up to 21. So we're going something, you know, like that-ish. And then 65.7. So that'd be 10, 20, 30, 40, 50, 60. 65.7 is quickly getting off our graph here. So that's all that you're doing there. And, of course, this does not keep going on, because this is where it ends. So it would have a starting point here with that, and then this would go on, because our n, our domain, which is why I've been doing that domain stuff, you can see that the domain is when n is greater than or equal to 2, so it'll be all those values there. That's it. If you can plug this into your calculator, and if you can graph it, that's what you need to be able to do for the homework. So let's take a look at that homework quick. If you want to pull that up here. So this will be right down here. It should be growth and decay PDF. So why don't you pull that up? Just about done here. Let me know when you've got that pulled up there. And I want to point out a couple of oddities with this one. Question.
Right, the common ratio, how would you find something for one that's going down?
How would you find?
Like the common ratio and then the percent.
Yeah, so let's see if I can find an example that's going down. B is going down. Yeah, so we'll do it on B here. Yep. So, which is even better for you because I'm going to assign B and D. And the weird thing about this worksheet is that this number 1, 2, and 3, they all apply to each other. So if you can see on 2 here, they identify the sequence in exercise 1 as it grows. So we'll just follow through. You'll do B and D. You'll do B and D for 1, for 2, and for 3. And then just to finish off, since we're putting out problems here, for graphing, you can just do B on this number 4. And then I'll have you skip number 5. I like it. I think it's a good one to look at. But I told the other class we could skip it. So we're doing B and D of 1, 2, and 3. And then we're doing B in 4. And that's it. So real short assignment tonight. So let's take a look at B here. Give you a little kickstart here. So starting off, what would be our common ratio here? So we're just taking that number, dividing it by that number. So when we plug this into our calculator, let me know what you get out of that. .399. So our common ratio then be 0.399, because this little formula here is always going to tell us what the common ratio is. Now the common ratio is going to be different than my percent change. So going down to our second step here, what would be, is this growth or is this decay? Is it growth or is it decay? Decay, yep. Perfect. We'll be doing a lot of growth. Percent change. So now, how would we write this number in terms of 1 minus something? How would we write 0.399 in terms of 1 minus some number? What's that? 39.9. So let's say that we put, I'm guessing 0.39.9. If you do that, what does that end? What's the end result of that? 0.6 minus 0.601. So what is this result here when you type this into your calculator? You do 1 minus 0.601. What does that give you? 0.399. Yep. So this is part of the reason why you want to be sure and separate these ideas of common ratio and percent change, because this percent is very different than this. So this percent change here, this would be 60.1%, in theory negative, because it's a decay. Whoops, wrote it in the wrong line. Should go there. Make sense? All right. So then I will let you do the last part of this. I think that we're good at writing recursive formulas now, or recursive rules is another word that I've been using to describe that. So that's that. That's the video. You guys have the rest of the hour to work on the homework. About 9-10 minutes here. You might even get through it all.